Hello everyone, welcome to MBA Karo. Today is day 25 of hot summer series, and in this video we are going to solve questions based on polygons and circles. So in the previous video on geometry we did mensuration, and today we will see polygons, quadrilaterals, hexagon, etc. and questions on circles. If you are new to the channel, please don't forget to subscribe to the channel and follow us on social media platforms. So we are on day 25, 5 more days to go, in which one of the topics, one more class on geometry, that would be on triangles, and a couple of classes on DILR and also on sentence filler and modern maths. That would wrap up this series, which will prove very beneficial for you to prepare for CAT and other MBA entrance exams. In case you are looking for a structured preparation for CAT, you can enroll in our CAT batch, and in case you use this code HOT, you can get 20% off till the end of this month. So try to solve the questions on your own and then look at the solution to get the best results. So this is the first question sitter to start with. In this figure we are given some angles, and which of the following relations is correct? So we need to find the value of x in terms of a, b and c. Okay, so this angle is a, and this says 180 degree minus b. So this angle is also going to be b, because this angle is going to be b because it's a straight line. So when you have a straight line, the sum of angles is 180. This is a, so this angle is also going to be a. Now if you look at this triangle DAC, this is the external angle. So external angle is sum of opposite to internal angles. So this is B plus C. So when you have an external angle in a triangle, this angle is equal to, this was C and this is B. The simple reason is because this is 180 minus B plus C, and this has to be B plus C. Okay, so this angle is B plus C. Now x is an external angle, and this angle is B plus C, and this angle is A. So this angle is equal to A plus B plus C. So x is A plus B plus C. So no need to substitute any values for ABC. Just use the common property of external angles in a triangle and get the answer. The lengths of two sides of a parallelogram are 5 cm and 11 cm. What is the sum of the squares of the diagonals of the parallelogram? So we have a parallelogram. It says the sides are 5 and 11. Okay, and you need to find the sum of lengths of squares. So let's say this parallelogram is ABCD. Okay, we need to find AC square plus BD square, sum of squares of the diagonals. Okay, now what most people would do is they would draw up a perpendicular here. Okay, let's call that height h, and they will take this distance x and maybe draw another perpendicular this side, okay, to find the relation. Okay, so that's how a conventional method of solving this problem is, right? You draw the perpendicular h, you get this as x, and then you get this as 11 minus x, and then you will say 11 minus x square plus h square is this, and then here you draw another perpendicular with this height is h, this will also be equal to x, so h square, and this will be, this complete line will be from here till here, this is 11 and this is x, so you will say 11 plus x. So you will take the squares of all these and add it, okay, wherein you will get some algebraic expressions, and you will obviously be able to solve it, right? You will be getting some equations, the variables will be ruled out, etc. But a better way to solve it is, see, it says a parallelogram, right? A parallelogram can be any special parallelogram also. It's not necessary that you have to draw a parallelogram like this. A rectangle is also a parallelogram, isn't it? The opposite sides are parallel, the opposite sides are equal, so it is a parallelogram. Okay, so it's a special parallelogram. Now if you have a rectangle in place, you can easily find this. So this is 5 and this is 11, so root 5 is 25 plus 121, that is root 46. and this is also root 146. So both diagonals are equal. Sum of the squares of the diagonals. So 146 plus 146, the answer is 292. Simple answer, just taking a special polynomial. So if they say that is a parallelogram, you can take a special parallelogram and get the answer. So remember this thing in geometry, that you need to learn how to deal with special figures. So if they just mention that it's a triangle, you can assume it to be an equilateral triangle. In the given figure, ABCD is a rectangle. AE ratio AB is 3:7. Okay, this is 3:7, and AF ratio AD is 2:5. Right? If area of AECF is 82, we need to find the area of ABCD. Okay, so how do we solve this is, let us say this complete length is 10x, so this will be 3x and 7x. This length be 2y and 5y, so total is 7y. So now this rectangle can be divided into three parts. One is this, another is this, and this is the third part. Okay, now what is the area of this part? 7x, and this is 7y. So if you multiply and take half, because half base into height, so 24.5 xy. Okay, now this area is 5y, this length is 5 and this is 10x, so 5 into 10 is 50. Okay, 50 and half is 25 xy, and we need to find this area in terms of xy. Now if you look at the total area is 70 xy of the complete ABCD. The area is this much. Now we will subtract these two, minus 49.5 xy, so we will get 20.5 xy. That is equal to 82. So this gives us xy is equal to 4. If xy is equal to 4, so we have the total area is 70 xy, which is 280 square units. So this is how we can solve this question. It was quite an easy question to solve. You just had to take the sides in that particular ratio and find the overall area and subtract the area of these two triangles to get this area and find the complete area. In a rectangle ABCD, P is a point situated inside it. If PA is equal to 9, PC is equal to 24, PD is equal to 18, then find PB. So this is a standard question. I'll leave the derivation up to you, giving you the hints. You can find out the derivation, but I'll tell you the direct way to solve it. So we have ABCD, okay, and there is a point P such that PA is equal to 9, PC is equal to 24, PD is equal to 18, and we need to find the length of PB. So I'll give you a hint how to get this proof. Okay, so draw perpendiculars like this. So that let these lengths be A, B, C and D. So find these points, find PA square, PB square, PC square and PD square in terms of ABCD, okay, and you will get the proof. So the theorem says that in this case PA square plus PC square is equal to PB square plus PD square. Need to know the result. Okay, derivation you can derive on your own. Like I have given you the hint, I have drawn 4 perpendiculars. Okay, use Pythagoras theorem and find it. Like for example, PA square will be A square plus C square. Okay, so likewise you find for all and you will get this relation. Okay, so we need to find PB square, we need to find PB. So PB square, PA square is 81, PC square is 576 and PD square is 324. So we will get PB square is equal to this will be 252 plus 81, 333. Okay, so PB is equal to under root 333, which is basically 37 into 9. 9 comes out as 3 root 37. So this is a standard result that one must know in this special kind of question. Okay, if you know that result, great. A rhombus has an area of 12 square centimeter and a side length of 5 centimeter. Then the length of its longer diagonal is. So this was a question which was asked in CAT 2021. Okay, if you see the solution on different platforms, you will see that, like आपको solution दिखाता हूँ, what would be the solution be? Okay, you would be given that, let's say this is the rhombus. Okay, so longer, let's take this is the longer, this is the shorter. Okay, and this is 5. So area is 12 square centimeter. So this is A, this is B. So area is half 2A into 2B is equal to 12. Okay, so we get 2AB is equal to 12, right? So AB is equal to 6. Then A square plus B square is equal to, you will get 25. Okay, so like if you use this equation, you will get the area, like you will get A plus B is equal to root 37, because A plus B plus A square plus B square plus 2AB is A plus B ka whole square. Okay, and A minus B is equal to root 13. Okay, so we need to find the longer diagonal. So if you add these two, we will get 2A is equal to root 37 plus root 13. Okay, so 2A is the longer diagonal. So we will get this answer. Okay, this is the algebraic way to solve this equation. Okay, and getting the answer. However, one can use these values. See, remember, these square roots make you confused in geometry. Okay, if you get confused by these square roots and you look at the options, you get nervous, then that's a problem. Now I'll tell you a way how to solve this question with these. See, you should approximately know what is root 37, what is root 13, what is root 12. Okay, so root 37 is approximately 6. Now 3.5 ka whole square is 12.25. Okay, so we can take root 13 and root 12 approximately 3.5. Okay, so basically root 13 is 3.6 and this is close to 3.5, 3.45 or something. So let's take 3.6 and 3.5 respectively, and this we will take as, let's take 6.1, or for simpler calculations you can take 6 also. Okay, now see this thing, root 37 plus root 13. Root 37 is 6.1. Okay, root 13 is 3.6. Okay, so this divided by 2, so you can say 9.7, that is 4.8. So definitely 2A will be longer than this. Okay, 2A will be longer than this side. So this is not true. Now this value is 9.6, possible. Okay, possible value. Root 13 plus root 12. Root 13 plus root 12 is how much? You can take 7.1 by 2, that is 3.5 or 3.6. Okay, 3.55 you take. This is 7.1. Okay, now let's look at one thing, that like which of these should we choose? Should we choose 9.6 or 7.1 as the answer? So look to this thing carefully. See, if both of them were equal diagonals, okay, so if A was equal to B, then 5 would have been root 2A. Okay, or A would have been 5 by root 2, 2A would have been 5 root 2. Okay, root 2 is 1.4 into 5, that would have been around 7. So if both of them are equal, the approximate length would have been 7. Okay, so 7 would be the length if both of the diagonals are equal, but we are given that one of the diagonal is longer, so you can take a bet and mark this as the answer. So this is the jugaad way of solving questions, and like this is how I attempted this question in the examination. I got the same question in my slot, I was in the same slot and I got this question. So this is how you can tackle this such kind of a question with ease. So knowing these values, approximate values of square roots, help you estimate the answer. So this is 9.6. Now this is the next one. It is going to be an easy one. It says that ABCDE is a regular pentagon and sides AE and ED of the pentagon are extended as shown to form triangle EFG which is right angled at F. Vertices A and C are joined to form triangle ABC. What is the value of x plus y in degrees? So when we have a regular pentagon, so the side length angle is 540 by 5, that is 108 degrees. Okay, so all these angles are 108 degrees. Now we need to deal with x and y. So this angle is 108. So this angle is going to be 72. If this is 72, this is 90. Y is going to be 18. Okay. Now this is a regular pentagon, so all sides are equal. So this side is going to be equal to this side. This angle is 108. So x is equal to this angle, that will be 36, because 36, 108. Okay, so x is 36. So 36 plus 18, you get the answer as 54 degrees. So that was a quite simple one. You just need to know the angles in a regular polygon, and in case of pentagon, the regular pentagon, the angle is 108 degrees. The ratio of the area of a square to the area of regular hexagon having the same perimeter is. So area of square, all of us know, is s square. Area of regular hexagon is 3 root 3 by 2 s square. Okay. Now we are given a square and a hexagon that have equal same perimeter. Okay. So we have 4 sides. So let us say the side length is x and y. So 4x will be the perimeter, that is equal to 6y. 4x is equal to 6y. So x upon y is equal to 3 by 2. So let us take the side length as 3 and this side length as 2. We need to find area of square to area of hexagon. Area of square upon area of hexagon. Area of square is 9. Area of hexagon will be 3 root 3 by 2 into side square. Side is 2, so it is 4. So we get 9 upon 3 root 3 into 2. So that basically becomes 9 can be written as 3 into 3, or we can reduce 9 by 3, and 3 by root 3 is root 3. So this ratio is root 3 ratio 2. So one must know the formula for areas of hexagon, octagon, etc. A regular octagon is formed by cutting the corners of a square whose side is 6 centimeter. Find the area of the octagon. Okay. So now if you look at this thing like octagon. So first of all, one must know the area of octagon. Area of octagon is 2 root 2 plus 1 a square. That is the area of octagon. Okay. Now I'll tell you that how to solve this particular kind of question with ease. Now how does the conventional way look like? I'll show you that way. You try solving using that way, and then I'll tell you a direct way to solve it. So the conventional approach is this. So there is a square whose side is 6 centimeter. So this side is completely 6. The side is 6. So let us say the length of the side of an octagon is A. Okay, so all sides are length A. Octagon has 6 sides. So sum of angles is 6 into 180 degree. Okay, octagon has 8 sides. So angle, this angle is 6 into 180 by 8. That is 3/4 of 180, which is 135 degrees. So if this is 135, that means this angle is 45. So now this angle is 45, this is 45. So this side length A is root 2 times of this side length. So this basically is A upon root 2. Okay, so this side will also be A upon root 2. Now this is a symmetrical figure. So this side length is A upon root 2 and this is also A upon root 2. Okay. Now if you have to calculate this the side of octagon, so when you add all these, so this will be root 2A plus A, that is equal to 6. So you can get the value of A, root 2 plus 1, A is equal to 6. So you will get A is 6 upon root 2 plus 1, and then you will put in this formula here to find the area. Okay, and then you will get something in terms of root 2 and some values, right? Now these kind of questions are quite common in geometry, wherein you have to find inscribed area or all such areas. Now the thing is, if you go by the conventional way, you have to draw this diagram. Of course we will draw the diagram in the other case also. You have to find the value of A, you have to understand all this and do the calculations. Okay, so do let me know by putting in the values, do you get the same answer? Okay, so A is known to you. Now you need to find 2 into root 2 plus 1, A square. So you have to take square of this and calculate. However, there is a different way, which I told you that you need to know the root values. So root 2 is 1.4. Okay, so you can approximately take 1.4. So root 2, if you see these are root 2 minus 1 or root 2 plus 1. So this will be basically 0.4 and this is 2.4, right? So 36 into 0.4 is how much? 14.4. 72 into 0.4, double of it, 28.8. 36 into 2.4, that will be a very large value, 18 into 2.4. Now before even calculating these values, let us see the area of this square. Area of square is 36. Area of square is 36. You are cutting out some portion out of it. Yeah. So these two values, these are greater than 36. These two values will be much greater than 36, because if you have 36 multiplied by 2.4, it is greater. 18 into 2 is 36. 18 into 2.4 is greater than 36. So we can rule out two of the options. Now think, this is 14.4, which means less than half. Less than half. But if you look at this figure, right, do you think that less than half is being removed? See, if you see this is half part, right? So they are removing less than half. Like, see, this part is removed, so the remaining part is more than half, right? So it is definitely, the remaining part has to be more than half. It has to be greater than 18. So this becomes our answer. Without making all these things, without finding the value of A, without dealing in these roots, we can answer the questions. As we saw in that case of that rhombus based question also, root values, because most of the students do not know these root values, or even if they do, they think of solving in this manner, and they always get confused that यहाँ पे 2 से multiply कहाँ पे होगा, 2 से divide कहाँ पे होगा, right? So better to use these approximations in geometry. That will help you a lot. So you should know the value of pi. So we will do some questions in embedded figures and circles also. Okay, so you should know the value of pi, you should know the value of root 2, root 3. So knowing the irrational values help you a lot, which most of the aspirants do not use. So if you use these methods of putting irrational values and solving it, then you are much better than most of the candidates. So the answer is going to be root 2, 72 into root 2 minus 1. Someone please try solving this question by putting this value of A in this equation and getting the answer, and do let me know in the comments that if you got the same answer or you got a different answer from it. I hope you are enjoying this series, and today's video will improve the way you solve geometry questions and will teach you a lot of theorems also. Now let's move on to the next question. Now let's solve questions based on circles. In the given figure, A, B, C, D, E, F are points on a circle. which of the following is the diameter of the circle? Now this question looks peculiar, that why are they asking which of the following is the diameter. Okay, so we have triangles given. So this is 10, 80, this angle is going to be 90. 5, 95, that is 100, this angle is going to be 80. Now we have a theorem that if there is a diameter, the angle is 90 degree in that circle. So this is 90 degree, this means AD must be the diameter. If AD is the diameter, then we shall have, so AD will be the answer. So very simple question, testing the basics of the theorems on circles. In the given figure, AD is equal to DE, find the value of X. So theorems based on chords and external chords, etc. Now AD is equal to DE, right? Also see, this is a, like if you look at this quadrilateral ABCD, this is a cyclic quadrilateral. Okay, so this angle, if it is 110, this angle should be 70. So if this is 110, this angle is 70. Okay, this angle is 70, so this angle is going to be 70. If this is 70, this is going to be 40. Okay, now look at this angle, this is 110, this angle is going to be 70 degrees. This is completely 180, 40, 45, 85, and this is 95. So 95 plus 70 is 165. So X is going to be 15 degrees. So you need to be very well versed with the theorems on circles. Please go through the theorems, and as an advice, what I would suggest is, there are some people on social media, influencers and all, they sell their formula notebook, right? They will say that download our formula notebook, that will help you. No, let me tell you, those formula notebooks are useless until and unless you make your own formula notebook. So make a formula notebook, write all the theorems. Whenever you sit to practice, ensure that you look at the formula notebook and try to see that which formulas, which theorems will fit in which question. Okay, in the given figure, chord ED is parallel to the diameter AC. Okay, if CBE is 65, you need to find angle DEC. So we need to find angle DEC. So obviously we will have to join this. Okay, it is given that ED is parallel to AC. So if ED is parallel to AC, if we have to find this angle, we have to find this angle. Okay, now AC is the diameter, so this angle is going to be 90 degrees. Okay, so these are applications involving multiple theorems on circles. Okay, so go through the theorems on circles and you will find these questions quite doable. So this angle is 90 degree. Now if you look at this, there is a theorem which says that if there are two angles like this, they call it angles in the same segment. You do not need to remember the wordings what they say, just know that if two angles are like this, they are equal. So if this is 65, so this is also going to be 65 degrees. This is 65, this is 90 because it is the diameter. So 65, 90 is 155, this remaining is 25. If this angle is 25, then this angle is also 25 degrees. So this is how the theorems are applied in circles. You need to be aware of each and every theorem of circle. Ensure that you note down all the theorems. Whenever you solve questions, think, like, go through all the theorems and see which theorem can be applied in figure. And this is how you improve your problem solving in geometry. People think that मुझसे geometry के problem solve नहीं होते. The reason is, like, you just read the theorems one, that's it. Ensure that whenever you solve questions, keep the formula notebook with you. Check each of the theorems, like, okay, angle in a like semicircle, right? Angles in the same segment. If this is matching, that is matching. So that's how you solve the questions. Okay, so here's the next one. In this given figure, angle O is the circumcenter of triangle XYZ. Tangents at X and Y intersect at T. If angle ZOX is 140 degree and XTY is 80 degree, find OZY. So again, it's an interesting question. So we need to find OZY. Okay, now O is the center of the circle. Okay, circumcenter of triangle means it's the center of that circle which is around the triangle. Now this is a tangent, TX is a tangent, so this angle is going to be 90 degrees, right? Okay, now see carefully. We know that tangents from the same point are equal. So there are multiple theorems being applied in this. One is the tangent theorem, two theorems related to tangents. One theorem which says that the tangents are equal. Another is that this angle is 90. So if this is 80, this angle is going to be 50. Okay, and this angle is also going to be 50. If this is 50, the remaining part is going to be 40 degrees. So basically OXY is 40 degrees. Okay, so this part was 50, this is 40. Now another theorem that will be applicable in this is, see, in geometry, especially in circles and triangles, there will be a mixture of multiple theorems, right? It is not that one theorem will be applicable, there will be several theorems that will be applicable. So if you look at this circle, this angle is 140, and there is a theorem which says that if you draw an angle like this, that is double, the angle at the center is double. So this angle has to be 70 degrees. This angle is 70, right? So this 50 was not needed, okay, because we did this 50 to equate these two as 50. So this is 70. Now this is 140, so remaining part at angle O will be 220 degrees. Okay, so now you look at this quadrilateral. This angle is 220, this angle is 40, so total has to be 360 including all these four. So this is 260, 100 degrees left, this is 70, this angle should be 30 degrees. So we had three theorems being tested in this problem. So that's what will happen in case of these circles. You will have multiple theorems being tested in a single question. So the three theorems that are being tested is that the tangents are equal. Okay, second theorem is that this is 90 degree, and the third theorem is the angle at center is twice the angle at the circumference. So mixture of three theorems. If you know all the theorems, then you are able to solve this question. So it's very important to know all the theorems in circles. AB and CD are two chords of a circle such that AB is equal to 6 and CD is equal to 12, and AB is parallel to CD. If the distance between AB and CD is 3 cm, find the radius of the circle. Okay, so let's draw this. So these are two chords. Okay, so it says that AB and CD are two chords. AB is equal to 6 and CD is equal to 12. Okay, okay, so AB is 6 and CD is 12. So there is a theorem which says that CD is 12. So when we draw the perpendicular, okay, so you can draw a perpendicular like this from the center, it cuts the chord into two equal parts. Okay, that's a theorem of chords. So this part is going to be 6, and similarly if we draw a perpendicular from here till here, it will divide into two parts, that will be 3. Okay, so let's say this is R. Okay, this is the radius R. Okay, and this side is given as X. This total is given as 3. So let us say this is X and this is 3 minus X. So we will get X square plus R square is equal to X square plus 36 in the first triangle. In this triangle, R square is X square plus 36, and in the second triangle it is 3 minus X ka whole square plus 9. Okay, so we will get X square plus 36 is equal to X square minus 6X plus 9 plus 9. So X square get cancelled. So 6X, now this X it becomes negative. So what is the flaw that we did in this question is, we took the chords on opposite side of the center. So it is possible, see we are not given that it is on which side. So we will have to take another case wherein the chords are on the same side of the circle. So we will redraw this figure. So we will take another scenario when they are on the same side of the circle. Okay, so now we will have this thing, this part is 3, this part is 6. So this is the radius r and this is the radius r. Okay, and we need to find the radius of the circle. Okay, now this distance between them is 3. Let us say this part is x. X is from O to, so AB is 6, CD is 12. So let's say this is CD, E and F. So this is E and this is F. So OF is equal to X. Okay, so when you look at this triangle OCF, in triangle OCF, R square is equal to, this part is 6, we say that it cuts into 2 equal parts, so R square is equal to X square plus 36. In the other triangle which is OEA, R square is equal to, this part is 3 because it cuts into 2 equal halves. Okay, so this part is 3, so 3 and this is 3 plus x, x plus 3 ka whole square plus 9. Okay, so we will just equate this and get the result. So x square plus 36 is equal to x square plus 6x plus 9 plus 9. Okay, so x square get cancelled. Now we will get 6x is equal to 18 or x is equal to 3. X is 3, so r square is 45, r is root 45, so which is 9 into 5, so there is 3 root 5. So this is the answer is 3 root 5 centimeter. Okay, so this is how we find the radius of the circle. Okay, so this is again a theorem, quite useful theorem which is often tested. The chords and the perpendicular from the center to the chord, it bisects the chord. Okay, so here is the next one. It says that in this given figure, find the length of chord AB. So we are given a chord and we need to find its length. Now there is a chord intersection theorem which says that, let us say this part is let us call name these chords for now, CD, EF, and they meet at P and Q. Okay, so there is a theorem which says that when two chords intersect, okay, so for example if we are considering CD and AB, so when two chords intersect like this, okay, they are intersecting at P, this is C, this is D, and this is A and this is B. So the theorem says that PA into PB, the meeting point, two opposite directions product is equal to PC into PD. So that is the theorem of chords. Okay, so now what we will do is, let us say this length is x and this length is y, right? Now one thing that you will notice is, like P, so we will apply this theorem in these two chords, like applying on AD, AB and CD. When we apply this theorem, it gives us that x into y plus 14 equals 12 into 20, which is 240. Okay, second, if you take these two chords, if you take, so this is EF and AB, so when you take these two chords, so the theorem says that y into this part is x plus 14 is equal to 240. So in both cases the values are equal. So let us equate these two. So we will get xy plus 14x is equal to xy plus 14y. Okay, so now we will see this xy can be cancelled, so x is equal to y. So we can put in any of these equations. So we will get x into x plus 14 is equal to 240. So we get x is 10, 10 into 24 is 240, right? So x is 10. So this length is 10 and this length is also 10. So we need to find the length of AB. So 10 into 10, 10 plus 10 plus 14. The total length is 34. So you will get as the answer. So 34 is the length of this chord. Okay. So this is how we solve this question. Okay. So again, this is another theorem which is on chord intersection theorem. And there have been questions on this theorem directly being asked in CAT, ZAT and several examinations. So one must know all these theorems related to chords, tangents, and then angles, right? If you make segments, etc. I hope you are enjoying these sessions, and don't forget to like this video and share it with your friends. If someone asks you that they want a revision video on geometry, so do recommend this video, because this will clear a lot of your concepts and will show you great ways of solving problems. Okay, now let's proceed to the next question. In the given figure, the diameter AB and chord CD of a circle meet at P. PT is a tangent at T. CD is 7.8, PD is 5, PB is 4. You have to find the radius of the circle. So too many things given here. So this covers another aspect, which is tangent and secant theorem. So let's look at the theorem and see what does it actually mean. So when we have a tangent and a secant, okay, so remember this, like tangent secant theorem says that let's say this is the tangent, okay, and this is the secant. So the tangent secant theorem says that if you have a tangent PT, so PT square will be equal to, like any secant, if you take P to D into P to C. So basically the point, the starting point to one of the end points and to other end point. Okay, now similarly it will be equal to PB into, now this is also a secant. Secant is a line which cuts a circle at 2 points. So PB into, this is PA. So that is the property which is given over here. So we need to find the radius of the circle. So too many things given here. So let's look at this. Okay, and what we are given, that CD is 7.8. So this is 7.8. PD is 5. PB is 4. Right. So PB is 4. PA is not known. PD is 5. PC is 12.8. So 12.8 into 5 is 64. So that means PT is 8. Okay, so this basically, this is also should be equal to 64. So PA is 16, right? Now PA is 16, that means PB is 4. So this AB will be 12, right? And we have to find the radius of the circle. We are given that diameter is AB. So AB is 12, thus the radius is 6 centimeter. So now if you realize that these questions are not difficult at all, just the thing that you need to know the theorems well. So in geometry, ensure that you go through all the theorems on circles, triangles, etc., because that is what and if you have a good practice of these questions, you are definitely going to get these questions right in the examination. Okay, so that's the answer, 6. Okay, so here's the next question. It involves on common tangent. So it says in the figure, line AB is a tangent to both the circles touching at A and B. Okay, so when you have a tangent, it is perpendicular from the center. So this is perpendicular, this is perpendicular, right? Now if OA is 29, so we have OA as 29 and PB as 18. We need to find the length of AB. Now this particular question will require some construction. Okay, how can we tweak? We need to apply some tweak in order to solve this question. So how do we solve this question is, basically, see, this is a figure wherein we have, like, forget these circles, like think of this as a figure wherein these two angles are 90 degree. Okay, one side is 18 and you have a trapezium sort of figure. Okay, Now if one could draw a perpendicular like this, imagine drawing a perpendicular like this, then what would happen is, we know the side length 61. Okay, now this is 18, so this is also going to be 18. This total was 29, so this is going to be 11. And since this is a rectangle, this side is equal to this side. So if we can find this side length, that is, let us call this point C. So PC, AB is equal to PC. Okay, so this is, let's say, point C. So AB is equal to PC. So how do we find PC? Just use Pythagoras theorem. So root 61 square minus 11 square. 61 square is 3721 and 11 square is 121. So this is root 3600, which is 60. This is 60 centimeter. So just bit of a tweak to make this into a rectangle and then solve it. Okay, so a lot of theorems are indirectly tested. Now in this, the theorem tested is the tangents are perpendicular to the center. So if you join the tangent to the center of the circle, it is perpendicular. So we got two right angles, and now we converted into a rectangle, and we found this side length, and hence we solved for this side. So I hope you enjoyed solving these questions. Here's the next one. It's an easy one, and I guess this question you could solve without even looking at the solution. So it says that PQRS are points on the arc of a circle, that PR is the diameter of the circle. Okay, PR is the diameter. Then it says that PQ is 7, so PQ is 7 and QR is 6. Okay, this is 7, this is 6, and RS is 2. Okay, it's a very simple question. You need to find a perimeter of the cyclic quadrilateral PQRS. Now PR is the diameter, so this means, okay, RS is, so what we have, PR square will be PQ square plus QR square, and also it will be equal to PR's RS square plus PS square, right? So PQ square is 49, this is 36, PS square is 4, RS square, PS we need to find, RS square is 4. So this is 85, PS square is 81, so PS will be 9. We need to find a perimeter. So 7, 6, 13 plus 11, 24 is the perimeter of this quadrilateral. Okay, it's very simple question. Just that if you are given a diameter, you know that the triangle formed is a right angle triangle. Okay, so that was the key here. Simple question. I hope all of you must have got this one correct. Well, let's move on to the next question, and this is an interesting one. Two mutually perpendicular chords AB and CD intersect at P. Okay, so we have to draw two perpendicular chords. AP is 4 and PB is 20. So AP is 6 and 20. And okay, AP is 6 and PB is 20. CP is equal to n, right? Now the thing is, how do you find this area of a circle? This is a tough question. Okay, now it involves a couple of theorems. First is intersecting chords, right? So what did we talk about in the intersecting chords? We discussed that if two chords intersect, then PA into PB will be equal to PC into PD. So first of all, we will find the length PD. So PA is 6, PB is 20, PC is 10, so PD has to be 12. Okay, now it does not look like 12, so let's of course you are not supposed to measure the lengths, but yes, so that it does not look very awkward. So it is 6 and this is 20. Okay, now this is 10 and this is 12. Now we need to find the area of the circle. How would we get the area of the circle from this? Okay, so one theorem was intersection of chords theorem. So this is theorem 1 tested here. Next we will use, now these two are perpendicular, right? So another theorem is chord and chord bisector theorem. So from the center, if we draw perpendicular to the chords, that bisects the, so that is the second theorem that we will use in this case. Suppose the center is somewhere over here. Okay, the center is over here. So if we draw, let's take it this side somewhere here. So when we draw a perpendicular, it will cut the chord into two equal parts. So let us draw a rectangle like this. Why we are drawing rectangle? To get perpendicular this side as well as this side. Okay, now what is the length of chord AB? AP was 6 and PB was 20, so total length is 26. So it will be divided into 13 and 13. Okay, now CD, it is 10 and 12, total is 22. So it will be divided into 11 and 11. Okay, so now let us see how do we solve this question. So from here till here, I'll use another pen to demonstrate this. So this is 13. So this part is 13 till here, the length is 13, and we have this radius r. Okay, now if you look at this part till here, it is 11. Okay, now this is 11, so this is 10, this should also be 11, like this is cutting into half, this should be 1. Okay, so this is 1 and this is 13. So r square is equal to 13 square plus 1 square, that is 170. So area is pi r square, that is 170 pi centimeter square. Now you could do it from the other triangle also. Like for example, if you take this triangle, you can get using this triangle also. See, this part is 13. Okay, so till here it is 13. So this is 6, this should be 7, right? So this length is 7. Okay, and this is 11, right? This part is 11 because it is half. So you can again get 11 square, 121 and plus 49. So if you take r in this triangle, you will get 121 plus 49, which is again 170 only, right? So either triangle you take, whether you take this blue one or you take green one, you will get the same radius. So this is how we will find the area of this circle. So it was a beautiful question, a tough one, and it requires some construction. Remember, the usual construction in like geometry is either join the diagonals. In case of circles, join the center. In case of triangles, maybe draw perpendiculars. So these are some useful constructions, right, that will help you solve questions. So in case of circle, join center. Okay, in case of circle. In case of rectangle or square, make diagonals. Sometimes, right? It's not that a universal thing. Okay, sometimes you will have to draw parallel lines. Okay, in some cases, like in triangles, you will have to draw perpendiculars, etc. That help us because these are certain universal theorems. Like Pythagoras theorem is quite useful in different, it has several applications. So even in circles, you have this theorem of Pythagoras theorem, which is applied in two cases. One is that if you have a diagonal, then the triangle is 90, the triangle is a right angle triangle. Also when you have a chord, so remember, whenever there is a chord, from center it bisects the chord and it is perpendicular to that chord. Okay, so now this is even more challenging question, and let's try to solve this one. Try to solve this question on your own, and if you are not able to solve, then please look at the solution. I'm sure that you are going to love this question. Okay, so in this question we are given, actually I got this question from some Instagram page. Okay, so there are some Instagram pages which I follow. You can search for geometry. There are a lot of questions on geometry that you'll find on Instagram which are quite interesting. So I follow those questions. I copied, like I've taken this from that source. Now in this case, DAQ is an arc of a circle. Okay, PQ is 7 centimeter and PA is 5 centimeter. Okay, and you need to find the area of triangle POB. So how do we solve it is, we are just given a arc of a circle. So why not complete this circle? Okay, now if you see this circle, the radius of the circle is r. So if I complete this circle, I see two chords. One is this chord, one is this chord. Okay, we discussed the property when chords intersect, right? What is the result that you get? Okay, now this part is how much? R, which is the radius of the circle. Now this part is also r, O to A is r, this is 5, so this is r minus 5. So from here till here, P to this point, let us say this point is C, PC, this is 2r minus 5 and this is 5, right? And this is 7, this point, this distance is not known. Okay, so let us say this distance is x. Okay, so x into 7, 7x is equal to 5 into 2r minus 5. So that is what we will get as the chord intersection theorem. Now this is a right angle triangle, this is r minus 5, this is r, so x square will be equal to r square plus r minus 5 ka whole square. Okay, now see, the x variable is redundant for us, we need to eliminate it, right? So instead of this, we can put x as this. So now put this in this equation. So what do we get? We get 5 times of 2r minus 5 ka whole square. So we will make it 25 by 49. We are squaring this x square, this r square plus r minus 5 ka whole square. Okay, so now we shall solve this equation to get the value of r. So it will be 25, inside we will get 4r square, 2 into 5 10 and into 2 20, minus 20r plus 25. Okay, that equals 49 times of, this will be r square plus r square, that will be 2r square, okay, minus 5r minus 10r plus 25. So a bit of calculation will be needed, or like one could have just guessed some numbers and got it that way as well. Okay, so when we see this thing, so we get 100 r square minus 500 r plus 625 equals 98 r square minus 490 r plus 1225. So we will get 2r square minus 10r minus 600 equals to 0, or further simplifying, r square minus 5r minus 300 is 0. So we get 15 and 20, so r minus 20, r plus 15 is 0. So we get r is equal to 20. Okay, so r is equal to 20, just need to verify that whether r is 20. Okay, so if we take this value 2r minus 5, that should be 35 and this is 5, and x is, so this is 15, this is 20, so this is 25, right? 25 into 7, 25 into 7 is 175, so is 35 into 5. So this satisfies that our this entire equation which we did was correct. Now r is 20 and this is 15, so we need to find the area of triangle POB. So this is half 15 into 20, that is 150 square centimeter. So this was a very beautiful question which I found on Instagram, and it is worth solving, and like I would pray that if CAT comes up with such an interesting question, I would love to solve this question. And of course it is not an easy question to solve, because it is difficult to think through it, because we are not given a complete circle. So it requires a thought process, that we are given just an arc, so we extend it, so this will become the complete chord, and we have two chords which are getting bisected, and hence we get this as the result. Okay, so another question which again I found on social media platforms, a good question. So we are given that DE plus LH is equal to 24 and EH plus DL is 40. You need to find the length of GF. Now the theorem is, like I'll tell you the theorem and then we will do it in a better way. So if there was only one quadrilateral, understand that this length is equal to this length, okay, this length is equal to this length, this length is equal to this length, okay, and this length is equal to this length. So basically in a quadrilateral, if you see, like, so let's make one line here. So let's suggest that is one line, okay. So the theorem says that whenever we have a tangent from external point, it has equal lengths on both sides. So we solved one question using that also. But now let us see that if there is a quadrilateral, then d plus e is 2 plus 3, okay, and this is like, if you compare these lengths 2, 3, 1, 4, 3, 4, 1, 2. So basically when you have a circle inscribed, this is a theorem which says that if there is a circle inscribed in a quadrilateral, okay, so let's say the side lengths are AB, CD, so that means AB plus CD equals AD plus BC, okay. So that is the theorem which says that the sum of opposite sides in such a quadrilateral is same, right? Now we will do one thing. Let us so now you know the theorem, we will apply this theorem and we will name these sides. So let us call this A, let us call this B, EF is equal to B, let us call this part C, let us call this D, let us call this F, E, F and G. So the theorem says that A plus G equals B plus F, okay. Similarly we have D plus G equals C plus E. So that's what we will get as the theorem, okay. Now when we add these, we get A plus D plus 2 times of G is equal to B plus C plus E plus F, okay. Now DE is A, LH is D, right? So A plus D we are given 24. Now EH is B plus C, okay, and EF is DL. So EH plus DL we are given as 40, okay. So we are given 24 plus 2G is equal to 40. So 2G is 16 or G is equal to 8. So the length of GF, the line segment GF is 8. So again it was a beautiful question applying the theorem wherein we have tangents from an external point, they are equal, they have equal length. So when a quadrilateral, a circle is inscribed in a quadrilateral, the sum of opposite sides is equal to is equal. So this side length is equal to this side length. So equating all these, we get the length of GF, which is 8 units. So in case you are preparing for CAT and other MBA entrance tests, we have launched this mock tests bundle, and in which we shall provide mocks for CAT and other MBA entrance examinations. You can check this out. We shall be launching the mocks whenever the exams are announced. We have already launched the free mock test for CAT, and we will be periodically launching these mocks in the coming days. And on this series we have got a great response by students, and a lot of students are asking for a fresh batch for CAT. We already have a batch running for CAT, so if you wish to enroll in the same, you can do so. And we will be launching a special crash course batch in September. So in case your fundamentals are already strong, if you are a repeater, you have practiced last year, okay, and you just need to brush up your skills, solve high level problems, and put intense efforts in the last 2-3 months. So we shall be launching a crash course for CAT in the month of September. So do subscribe to our channel and follow us on Instagram and Telegram, because these are the places where we shall be announcing this course. And be active on all the platforms, so that in case you miss out on YouTube, you may be able to you may get the notification on Instagram or Telegram about this course launch. So if you are interested in it, please wait till the month of September. Till then you can watch our videos on YouTube. We have had great content for different MBA entrance examinations. And here are a few questions for you to answer in the comments of this video. So 3 questions, 2 on circles, theorems on circles, and another on hexagon. So try to solve it using the method I told you, that cutting off pieces of a square we made an octagon. So it is similar to that. We are cutting an equilateral triangle and making a hexagon. So try to solve it using that process or some other innovative process, and do let me know in the comments of this video the answers to all of these questions. And in order to get the PDF of this class, please join our Telegram group. So this was day 25. We have 5 more action-packed sessions to come. So keep watching this series and do share it with your friends, recommend it to others, that this is the best revision series that you would find on YouTube, covering all the topics that are tested in CAT. So thanks again for watching this video. Have a great day ahead. Goodbye.